lower CO2 capture costs. Now, the activated carbon process, how does this work? So we noticed that some commercially available activated carbon materials have a catalytic activity property to convert the sulfur dioxide to sulfur trioxide and the lower oxides of nitrogen to NO2, which get absorbed at the surface of the activated carbon material. And then once the bed is saturated, the beauty about it is that you can regenerate the capability of this carbon material to absorb SOx and NOx by simply washing it with water when the higher oxides of sulfur and nitrogen converts to their corresponding acids, sulfuric acid and nitric acid respectively. And then you dry it and you start the cycle again. So basically you need at least 2 beds so that once one bed is an absorption mode, the other bed is washed and regenerated. And what we did, we started first with a bench unit. So the first thing to do is to look at various commercially available activated carbon material and to test if indeed for certain operating conditions the SOx and NOx are removed. And then we selected 1 or 2 materials to do a little bit a more thorough investigation and see what would be the optimum operating conditions to have high performance in removal SOx and NOx. And we started with what we call the bench unit. It's basically a tubular reactor having a diameter of 1 inch and about 1.5 inch height. So it's a very simple setup. So basically we are flowing gas from top to bottom. We have a simulated flue gas, and then we use a metering pump to simulate the humidity in this gas stream, which goes, as I said, from top to bottom. And then once the bed is saturated, we regenerate the bed by flowing water from bottom to top and collecting the wastewater. And this is how the bench unit looks like. So basically here is the tubular reactor wrapped up in this heating blanket